In this video, you are going to be introduced to chemical formulas. Now, who among you get this sudden urge to go to Watson's, Mercury Drug, or National Bookstore? Like, out of nowhere, you'll be like, I'll just look. I won't buy anything. I'll just go around. Then go home with bags like this. In my case, I do love going to Watson's as well. And I have this habit of looking at the nutrition facts or ingredients. Now, when I look at ingredients, I often see words that I am not familiar with. For example, this pan shampoo. It says here water, sodium lauryl sulfate, cocamidopropyl betaine, sodium citrate, sodium silene sulfonate, sodium lauryl sulfate, sodium chloride, etc. So I'm like,
What's up with that?
so let's focus on sodium lauryl sulfate. So what I do is I use Google. The first thing that comes up is an information from Wikipedia, which looks like this. And it's still very confusing. So you see here chemical formula, and when you browse for more pictures, you will see this and this. So what are these? What do they mean? To answer these questions, you have to know the basics of molecular formula.
What was that?
A molecular formula is the representation of a molecule that uses chemical symbols to indicate the types of atoms, followed by subscripts to show the number of atoms of each type in the molecule. Remember that a subscript is used only when more than one atom of a given type is present. Molecular formulas are also used as abbreviations for the names of compounds. For example, methane, CH4. This is used in LPG. We only have one carbon, so we don't put a subscript 1 next to C. And we have four hydrogen atoms, so we indicate 4. Okay? Next, we have structural formula. Structural formula for a compound gives the same information as its molecular formula. It means the types and numbers of atoms in the molecule. But the structural formula shows how the atoms are connected in the molecule. The structural formula for methane contains symbols for one carbon atom and four hydrogen atoms, indicating the number of atoms in the molecule. Now, these lines represent bonds that hold the atoms together. A chemical bond is an attraction between atoms or ions that holds them together in a molecule or a crystal. We will discuss chemical bonds and see how to predict the arrangement of atoms in a molecule later. For now, simply know that the lines are indications of how the atoms are connected in a molecule. So a ball and stick model shows the geometric arrangement of the atoms with atomic sizes not to scale. A space filling model shows the relative sizes of the atoms. These are for compounds. How about for molecules?
When I tell you what I'm about to tell you, you will be told my opinion.
Molecules are made up of two or more atoms of the element chemically bonded together, right? And most samples of the elements helium, hydrogen, oxygen, and chlorine are composed of molecules that contain two atoms each, called diatomic molecules. It is important to note that a subscript following a symbol and a number in front of a symbol do not represent the same thing. For example, one oxygen atom is written as O. Two oxygen atoms, like this, is written as 2O. Now it will be different if it's one oxygen molecule. It'll be O. Now if we have two oxygen molecules, it will be 2O2. We have the empirical formula. Empirical formula indicates the types of atoms present in simplest ratio. One example is benzene, C6H6. Benzene is a widely used industrial chemical. This is found in crude oil and is a major part of gasoline. So the empirical formula of benzene will be CH.
Period. Oh!